Hello to my viewers. Today I have a new topic for grade 8, which is the negative exponents. So as we know, negative exponent, for example, we have a base of a. We call this one the base. And this is the exponent. So if we have a raised to negative 1, we can solve this one as 1 over a. What if a negative 3? So this will be 1 over a cubed. Okay, so let's proceed for a good example for number 1. Number 1 example is 30 w raised to negative 1, where w is equal to 6. So as what I said, I need to simplify this base which has a negative exponent. So this will be 30, and this will be times 1 over w. Take note, where's the exponent one? The exponent one is in here, invisible one. And then I will put 1 over the 30. And then I will try to multiply 30 by 1. And same with the denominator. So I have here 30. Because 30 times 1 equals 30. Then 1 times w is w. Now I need to substitute w, which is equal to 6. So 30 over 6 is equal to 5. So, that's the answer for number 1. Let's move to number 2. Number 2 example. 1 over x raised to negative 3 times the round brackets I have here inside, the round brackets, x plus 2, where x is equal to negative 3. So, this will be 1, and this will be in the denominator for this term. So this will be x plus 2 over x cubed. Why? Because x raised to the negative 3 will be equal to 1 over x cubed. And then I will copy the numerator and then change this operation to multiplication and then upside down of this fraction. So this will be x cubed over x plus 2. Since there is no denominator in here, so I will put 1. And then start multiplying 1 by x cubed. So this will be x cubed. And then the denominator also multiply. So this will be x plus 2. Then I will substitute the value of x, which is negative 3. Negative 3 raised to the power of 3. And then this will be negative 3 plus 2. By the way, what is negative 3 raised to 3 power? So take note, if the exponent is odd, so the sign will remain. So if this is negative inside, so this will be negative. Okay, so 3, well, here is this one. 3 to the power of 3. So this will be multiply itself 3 times. So this is 9 times 3. 9 times 3 is equal to 27. So this is negative 27 because the exponent is odd. Then this one, what is negative 3 plus 2? This is unlike sign. So if unlike sign, we will use subtraction. 3 minus 2 is 1. How about the sign? The sign must be positive or negative. So negative 3 is bigger than 2 in terms of the integers. So 3 is having a negative sign, so this will be negative 1. So what is negative divided by negative? So negative divided by negative, that will be equal to positive. So 27 over 1. And we know that 27 over 1 is equal to 27. So that is for number 3. Okay, number 2, I mean. Number 3. Number 3, example. So I have here round brackets m minus 4 raised to the negative power, where m is equal to negative 2. Again, I will solve this one by using index laws. So this will be 1 over round brackets m minus 4 raised to the second power. So I need to substitute the value of m inside the round bracket. So m is negative 2 minus 4 raised to the second power. So this will be 1. So what is negative negative? So if you have two signs, negative signs, so this will be, you can use addition. So this will be negative 6 because 2 plus 4 is 6. But the sign must be remained as negative because you have to take the common sign, and then this will be raised to the second power. So what is, okay, if the negative will be having exponent of even, so the sign must be positive. So this will be positive 6 raised to the second power will be 6 times 6 is equal to 36. So this is positive 36 and this is 1. So that's the answer for number 3. Now, move to number 4. Example. Number 4. R raised to the negative 4 minus 2 raised to the negative 2, where R is equal to 3. So again, using the index laws, this will be 1 over R raised to the positive 4 minus 2. Okay, take note, 2 has only an exponent of 1 and positive, so it will remain in the numerator. Over, this will be R squared. Because R raised to the negative 2 will be 1 over R squared. So this will be 1 over R to the 4th minus 2R squared. So I have to find my LCD. What is the LCD between R to the 4th and R squared? So this will be R to the 4th. So R to the 4th divided by R to the 4th, it will be 1 times 1, still 1. How about this one? R raised to the 4th divided by R squared. So by using index laws, when m is greater than n, so this will be 4 minus 2. And this will be equal to R squared. R squared times 2, that will be 2R squared. And then, I will substitute the value of R, which is equal to 3. So this will be 1 minus 2 times 3 squared over 3 raised to the 4th power. By the way, what is 3 raised to the second power? Meaning you have to multiply itself 2 times. So this will be equal to 9. How about 3 to the 4th power? Multiply itself 4 times. 3 times 3 times 3 times 3. Okay. This will be 9 times 9. And we know that 9 times 9 is 81. So, this will be 1 minus 2 times 9 all over by 81. And then this will be 1 minus 18 over 81. So what is 1 minus 18? So take note, unlike sign. So subtraction, 18 minus 1 is 17 over 81. So what is the sign of the numerator? Since 18 is bigger than 1, and then 18 is having negative sign, so this will be negative 17. So the answer for number 4 is negative 17 over 81. Okay, number 5. I think this is the last example for negative exponents. So number 5, this will be y minus 2 round brackets raised to the negative 3, and then the denominator will be round brackets y plus 2 raised to negative 3 power, where y is equal to positive 4. Okay, take note, it cannot be crossed out because they have different operation. This is subtraction, this is addition. Since almost the same, y and y, and then the constant are the same, the exponent also, but you cannot cross out this one because of the operation. Okay, so I need to solve this one by using index laws. So for the numerator, this will be 1 over round brackets y minus 2 raised to, this is positive 3. And then the same also in the denominator. So I will say this will be 1 over round brackets y plus 2 raised to the third power. Since this is a complex fraction, so I need to simplify this one. So take note, this is the numerator and this is also the denominator. So I need to change this one. So y minus 2 cube. This is division, so I will change the operation to multiplication and then upside down of this fraction. So this will be y plus 2 raised to the third power over 1. Okay? Then start multiplying the numerators. So 1 times round brackets y plus 2 raised to the third power will be y plus 2 raised to the third power. And then the same also in the denominator, 1 times round brackets y minus 2 raised to the third will be round brackets minus y minus 2 raised to the third power. And then I will substitute my y value, which is 4, inside the round brackets. So this will be 4 plus 2 raised to the third power over. This will be 4 minus 2 raised to the third power. So simplify inside the round bracket. So this will be 6 raised to the third power. And then how about this one? 4 minus 2, this will be 2 raised to the third power. So what is 6 raised to the third power? So meaning I need to multiply itself 3 times. 6 times 6 times 6. So what is 6 times 6? That will be 36. And then multiply by 6. So 36 multiplied by 6. This is 36. Carry 3. 3 times 6 is 18. 18 plus 3. This will be 200. This will be 21. So I have here 216. So from here, this will be 216 over 2 raised to the third power. So this will be multiply itself 3 times. 2 times 2 times 2. So this will be 2 times 2 is 4 times 2. So this will be 8. So the denominator will be 8. Okay, we'll check this one if this will be divisible by 8. So 216 divided by 8. So I will use 21. So how many 8 do I have in 21? Only 2. So 16. Since 1 cannot be subtracted by 6, so I will borrow from 2 and then this will become 1 and then this is 11. 11 minus 6 is 5. Bring down 6. So how many 8 do I have in 56? 7. 7 times 8 is 56. Then 56 take away 56, that will be equal to 0. So the final answer for number 5 is 27. That's all for this topic.